So next we're going to look at uh, the nitrogen cycle and a little chart here. Um, so you're seeing how nitrogen gets into the ground, and then how that nitrogen promotes the growth of trees and plants, and where the nitrogen comes from. So animals, the cows. I assume this is the dead cow, I guess. So you're seeing it goes from animals and animal waste, and then you're seeing dead plants here. So those combine, and that gets some nitrate into the soil. Also, it's really important that when you look at this, you read all of it and look down here. Nitrogen fixing bacteria on legumes, roots, and in the soil fix nitrogen from the air and rain so it can be used by plants. It'll usually give you a little key somewhere on here. So, question one, nitrogen fixing bacteria are found both in the soil on the roots of legumes like peas and beans. From where do these bacteria get nitrogen? So, you can look at the chart, but you're also seeing it right here. So nitrogen fixing bacteria says it right here, nitrogen fixing bacteria on legumes and in the soil, fix nitrogen from air and rain. So right there, that's going to be your answer. Easiest way to figure it out is just go ahead and look really at the chart and read everything that's on there. So which of the following statements is a conclusion about the nitrogen rather than a detail? So we're looking at this, and what's a conclusion we can make? Something that's not clearly stated in here. So we see like nitrogen oxides dissolve in rain. Okay, that's clearly stated. Dead animals, dead plants, that decomposes. So what can we make a conclusion based off of what we think, but not what's actually written there? So nitrogen oxides dissolve in rainwater. We saw that that's actually on there. Nitrogen fixing bacteria are found both in the soil and on the roots of legumes. The recycling of nitrogen through the biosphere involves many complex processes, or nitrate bacteria, ammonia, and turn into ammonium into nitrates. So your answer for this one is going to be the recycling of nitrogen, because it doesn't actually say that anywhere. It just gives you that feeling. You can tell that nitrogen and recycling, it's a really complex process, but it doesn't actually say that. So you just have to figure out like what's the best answer that sounds the most reasonable, and that's the one it does. It doesn't clearly state that anywhere on here, but the overall graph, that could be another title for it. So to increase the nitrogen content of the soil, many farmers spread synthetic fertilizers containing nitrogen compounds. What might an organic farmer who does not use synthetic fertilizers do to improve the fertility of the soil? So you're looking at using chemicals and things to get the ammonium and ammonia nitrates, as opposed to just using what's available, dead plants, animals, things like that. So not introducing any chemicals into the process from outside. So what one would you do? So switch to crops requiring more potassium. Well, that doesn't really answer the question, because we're looking for nitrogen compounds, and you don't want to add more like chemicals. Compost with plant and animal waste. Plant more non-leguminous plants. Well, if that's what the farmer's farming, then you can't just decide to farm something else. So that's not going to make any sense. And then switch to crops requiring more nitrogen. So the increase of nitrogen content of the soil, many farmers spread synthetic fertilizers. So they want to improve the fertility of the soil. So you don't want crops requiring more nitrogen. That's what you're trying to get to make the crops grow. So the only one that really makes sense is compost with plant and animal waste. So composting breaks down, and it's usually natural, organic items that you use to help your plants and whatever grow. So you're going to have to look at a little chart on this one. So like I said before on like the social studies ones, always make sure you read your charts and really look at what we're doing here. Knowing your X and Y axis is really important, like what the titles are. So this one's solubility of common compounds in waters in grams of solute per 1,000 milliliters of water. Solubility is basically the idea of something dissipating in water. So like when you add salt to water, you can watch it kind of dissolve. That's solubility. So you're looking solubility per gram. So this is the solubility of it. Basically how much of it you're going to add. And then this is the temperature of the water to get it to go ahead and disintegrate, basically. So you have sodium bicarbonate is a solid line, potassium chloride, kind of the lighter line, and then sodium chloride is the lightest line. So which of the following statements is supported by the information in the graph? So about 15 grams of sodium bicarbonate. So sodium bicarbonate, find 15 grams, which is right around here. Will dissolve in 100 milliliters of water at 10 degrees. Obviously not, because it's at 50. So you just line it up, X and Y. 50, 15 goes out to about here, so that's incorrect. 30 grams of potassium chloride will dissolve in 100 milliliters at 30 degrees. So 30 and 30, you find it here. That's also not correct, because 30 grams would have to take around, let's see, what would that be? Almost 36, 37, 36, 37 degrees, or solubility. And then if you look this way, 30, it's going to be not quite. So it's not 30 degrees, it's 10 degrees. So sodium chloride shows the greatest increase in solubility, then increase in temperature. So sodium chloride has basically no change. I mean, it's just flat almost all the way across. So it doesn't have the greatest change. Really, the greatest change is potassium chloride, it looks like. So process of elimination, it would be D. And that supports it because as the temperature rises, each one is more soluble. So this one, like I said, they're going to tell you most of the information that you need in a question. So following the scientific method, you don't have to worry about that because it tells you here's the scientific method. So you don't have to freak out and be like, oh, I don't know the scientific method. It's right here. A researcher conducted an experiment using houseplants. Match each action the scientist took to the step in the scientific method. So you're going to look at basically the scientific method from formulate a question to draw a conclusion, and then the testing and hypothesis. So it's going to give you 5 or 6 examples here, and then you just have to match them up into whatever category they go to. So formulate a question. So we look at this. A scientist wondered whether water at different temperatures might affect houseplants differently. So that's going to be a pretty good one because wondered right there means it's a question. So we'll go ahead and put B in this first slot. Collect data. So this one can be a little bit tricky. As far as testing and collecting data, it can get kind of confusing. But you look, so for 6 weeks, the scientists used water at 75 degrees to plant plants in group A. And group B, he recorded their growth during this. So that one, you would look and think, oh, that could be collect data. It's really not. That one is he's actually testing the hypothesis. So it's what the scientist actually does to draw his conclusion. So you look down here, the scientist researched. That's what you're looking for. So that's going in, looking around at books, other scientists, and other scientific possibilities, and kind of just getting a little research on how you should do your experiments. So we're going to go ahead and put C in this one right here. So C, form a hypothesis. So the scientists guessed that warm water might be better for plants than cool water. So a hypothesis is basically a guess. You're without scientific data. It's an informed guess. So, if you look up out in the sky and you see some clouds, you're like, hey, you know what? I hypothesize it might rain today. It's an informed guess, but it may or may not be true. So E is going to be his form a hypothesis here. Test the hypothesis. So we said this one right here. That's what he's actually doing. So we're going to go ahead and say A, and then draw a conclusion. So he's going to take all the information he has at the very end of his tests and things and kind of come up with a conclusion. So we look at this, and you can kind of do it pretty easily here. You look at the end of the 6 weeks. So end, that's going to tell you it's at the end of his whole thing. And then this is the data that he got from that. So your answer for this one is going to be D. So kind of this one, look at the wording that they use. Wondered is a question, so formulate a question. Researched is is collect data. Hypothesis is like a guess, and it says right there he guessed. So you can kind of figure that one out, and then just don't get confused with the collecting data and testing a hypothesis, because he has to have a hypothesis before he can test the data. Atoms are comprised of protons, neutrons, and electrons. Because an atom has an equal number of protons and electrons, it has a total charge of 0. So it's a neutral thing. Protons, remember, pro, positive. Neutron, neutral, no charge. And then that means electrons are negative. So what would happen if an atom lost an electron? So if you went ahead and took out this guy right here, what would happen? So in reading this, right now it's neutral because it has even protons and electrons. If you drop that electron that's negative, then what's going to happen? Think of a number line. If you take away a negative, what happens? You go positive. You're going forward. So it would become. It would gain a new. It would gain. The charge would become positive because you're losing your negative and the neutral, so it's going to bump this up and it's going to be positive. Neutrons don't really have anything to do with it. They aren't going to change. It's the atom that they're asking about. The charge wouldn't become negative because you're losing the negative, and it wouldn't remain neutral because you're losing the other side of the balance. So process of elimination, you're going to go with A. You might look at like neutrons and electrons and protons a little bit. If you want to study up on that, it can get kind of confusing sometimes.